All right, 96, limit as x approaches -3. I'm going to go ahead and wager a guess and say that there's a hole here. Um, it could also likely just be an asymptote. You can check quickly by doing some synthetic division. So let's take the numerator 4x squared plus 32x plus 60, and let's divide it by that -3. So pull that 4 down. 4 times -3 is -12. 32 and -12 is going to give us a positive 20. 20 times -3 is a -60. So I get a remainder of 0, which tells me that there is actually a hole here. If I had gotten a remainder other than 0, then that would have told me that there's actually an asymptote, and so I would have wanted to sketch a graph. But what this means is if I divide that by -3, I've essentially pulled a factor of x plus 3 out of that numerator. So what's left when you pull that factor of x plus 3 out? That 4 and the 20 are telling me there is a 4x plus 20 left, which means 4 times x plus 5 is left in the numerator. What's left in the denominator? Well, you could take that 3x cubed, that 0x squared, and that -27x and 0 constant term, and you could divide a factor of x plus 3 out of that to figure out what's left behind. So I could pull that 3 down, get a -9. I could pull that -9 down, give a positive 27. I could pull that 0 down, and then -3 times 0 is 0, 0 and 0 and 0. So this is telling me that what's left behind is 3x squared minus 9x when you pull out a factor of x plus 3. So what does that mean? Well, that means I could pull out a 3x, and I'll be left with an x minus 3 in the bottom. So in the numerator I have that 4x plus 5. In the denominator I have 3x times x minus 3. It's kind of messy right there. And so what can you do with that? Well, now we can plug in -3 and we can see what we get. So if I plug in -3 at the top, 4, -3 plus 5, bottom 3 times -3 times -3 minus 3 gives us some stuff. So 4 in the top, -3 plus 5 is 2. So 4 times 2 in the top. Over in the bottom, 3 times -3, let's call that -9. And then -3 minus 3 is a -6. So I've got a double negative, so that will cancel. What is left? Well, I've got a 2 and a 6. That'll leave me a 3 in the bottom. So I've got 4 over 9 times 3 is 27. That was totally a weird way to do that problem. What you would probably do, you could do that, but what you would probably do is you would look at this and you would factor it. So you'd factor out a 4. You'd be left with x squared plus 32 divided by 4 is 8x plus 60 divided by 4 is 15. So then you'd factor that again. 4 times x plus 3 times x plus 5 over 3x cubed minus 27x. Well, you'd pull a 3 out, you'd be left with, I'm sorry, you'd pull a 3x out is what you should pull out. Pull a 3x out, what's left? X squared minus 9, which means this denominator is really 3x times x plus 3 times x minus 3. And then we can see that whole is gone, so you're left with 4x plus 5 over 3x, x minus 3, which is the same thing we got the other way. It's probably just easier to factor it. But you get that, you plug in -3, and again you get 4 over 27.